Hello guys, my name is Engineer Holiday. We want to look at other technical questions about mathematical induction. And in this video, we are going to be looking at this particular one, which is proved by mathematical induction that 3 raised to power 2n plus 1 plus 2 raised to power n plus 2 is divisible by what? By 7. Now, this is a question given to us, and we want to go through it step by step. Step number 1. Now, what we're going to do is what? Show that it is true for what? N equal to 1. So we want to show that the equation is true for n equals to 1. Now, what we're going to do is to put n equal to 1. We're going to have 3 raised to the power of 2 into bracket 1 plus 1. Then plus what? 2, 1 plus 2. So what do we have now? We want to have what? 2 times 1 is 2 plus 1 is 3. So we want to have 3 raised to the power of what? 3 plus 2 to the power of what? Of 1 plus 2 is what? 3. So this one will give us what? 27, because 3 raised to the power 3 is what? 3 times 3 times 3, 27. Then plus what? 8, which is 2 into power 3. 2 raised to the power 3 is that 2 times 2 times 2 is 2 times 2 is 4 times 2 is 8. We will have what? 35. Now, purely looking at 35, if I divide 35 by 7, it will give me what? It is divisible. It will not give me decimal. So if you check, 35 is like what? 7 open bracket 5. So that means it is divisible by 7, because 7 times 5 is 35. So that one is already proof. Now the next thing, since it is true for n equals to what? 1, then step 2 will now be, now assume it is true for n equal to k. That is to say, based on the fact that it is true for n equal to 1. So that means that we want to base our what? Assumption on the fact that what? Step 1 have already it has shown that it is true for n equals to what? 1. Now, what we're going to do now, anywhere we see n, we replace it with k. So what I would have 3 raised to the power what? 2k plus 1 plus 2 raised to the power what? K plus 2. So that's what I have next now. Now, you leave it like that. Step 3, because that one is an assumption. Step 3 now, which is the last step, will now be what? Based on the assumption, of step 2, show that it is true for what? N equal to what? K plus 1. Based on the assumption of step 2, show that it is what? True for n equals to what? K plus 1. Now, what we are going to do now is that anywhere we see n, put k plus 1 from the equation given, from this equation. So what we're going to have now is, now we're going to have it as three raised to the power 2k plus 1 in bracket plus 1. I mean, in place of this k, put k plus 1 plus 1, then plus 2 into bracket what? K plus 1 plus 2. And what we're going to have there? K plus 1 plus 2. So this will give us what? 3 into bracket what? 2k plus 2 plus 1 plus 2 into bracket what? K plus 3. So what do we have now? We're going to have it as, we break it down. We're going to have what? 3 is power 2k plus 3 plus what? 2 is power k plus 3. Now, with this one, now we're going to improvise in the sense that, look at the board. Now, I can write this one as what? 3 is power 2k plus 1 plus 2, which is the same thing as, I can write this one as what? 2 is power k plus what? 1 or plus 2 plus 1. Now, which can be written as, remember in indices, a raised by what? M plus n is same as what? A raised by what? M times a raised by n. Basically, is what we learn from laws of indices. So what we're going to do now is I will take this one as my m, I will take this one as my n. So in other words, 3 raised by what? 2k plus 1 times 3 raised by 2 plus what? I'll take this one as my m, I'll take this one as my n. So these are 2 raised power k plus 2 times 2 raised power 1. So 3 raised power 2 is from here. This one becomes the 9 to use another base 3. So 3 raised power 2 is 9. So we can have 9 into bracket what? 3 raised power what? 2k plus 1 plus what? This one had what? 2 into bracket what? 2k plus 2. Now, in this case, now don't forget, I can write this one as 7. I can break this one down into 2 now. 7 into bracket what? 3 2k plus 1 plus what? 2 what? Into bracket what? 3 is by 2k plus 1. Don't forget that if you add these two together, you have 9. Why am I doing that? Let me show you. You have 2 into bracket what? 2k plus 2. Now, I want these 2 to be able to factorize. So 2 is here, 2 is here. So this one now is divisible by 7 because I've written it in as a multiple of 7. This is a multiple of 7. 7 can divide this one without remainder. Now, if I factorize the 2 out, look at what you are saying. Now be 2 into bracket what? 2 is common. If you bring 2 out from both sides, you would have what? Remaining 3 raised by 2k plus 1 plus 2 raised by what? K plus 2. Now, plus what? 7 into bracket what? 3 raised by 2k plus 1. Now, if you check this one very well, I want to show you something. You have already done with that question. This part is divisible by 7. And this part, we have proved it already. It is the same with this one. Look at this one. Look this one and look this one. They are the same thing. And this one is what? A replicant of this one. Just that this one is in form of k and this one in form of 1. So anything that is true for n equals to 1 should be true for what? Should be assumed true for n equals to k. So for n equals to k. So in that case now, this one is divisible by 7. Since this one is divisible by 7, so this side is divisible by 7, this side is divisible by 7. Therefore, the equation is what? Valid. And is what? It is what? Divisible by 7. By 7. So therefore the equation is what? Divisible by 7. So please take note of that. So we have proved this equation, and I believe that by the time you take a study of it, what we do here is to maneuver the word, because we are to assume. Based on the assumption, we have to show. And in showing it, because this one is different from all the kind of questions I've solved in other series. So just check this one and learn from it. Thank you very much. God bless you.